Welcome to Lecture L2G of Computer Programming Fundamentals. Computer Programming Languages, the 1990s. The 1990s introduced computer programming languages for the World Wide Web. A number of information technologies converged in the 1990s to make the World Wide Web a reality, namely personal computers, networking, client-server platform architecture, and the Internet. Personal computers or microcomputers provided the client side of the client-server platform architecture, a relatively inexpensive computer that could be made available to the masses. Remember Bill Gates' goal of providing a computer on every desktop? The server side of the client-server platform architecture was provided by a network or server farm of computers, a server farm of mainframes, mini-computers, and microcomputers. Surprise, the mainframe and mini-computer did not die, but became an integral part of the client-server platform architecture, particularly on the server side of the client-server platform architecture. The client and the server were then connected using local area networking protocols and layered network architectures pioneered during the 1980s. Protocols and architectures that were extended over to the Internet in the 1990s. For example, the TCP/IP protocol and the OSI model layered architecture. The Internet required a transport protocol and universal data format for the data transported. Enter HTTP and HTML. Next, computer software to process the HTML file was required. Enter the browser, for example, Netscape and Internet Explorer. What was missing but surfaced in the 1990s was the computer programming languages that took full advantage of these information technologies that converged in the 1990s. Convergent information technologies which precipitated an evolution in computer programming languages. Computer programming languages that produced web-based computer programming application solutions. The 1990s established the era for computer programming languages dedicated to providing computer programming application solutions for the World Wide Web. First, Python emphasized computer program code readability. To be successful in providing computer programming for the World Wide Web requires a user-friendly computer programming language. Achieving this objective, Python was developed to be easily understood by non-professional computer programmers as well as professional computer programmers. Likewise, Visual Basic extended the user-friendly computer programming language objective by adding the concept of visual rapid application development, a concept where the computer programmer generated the majority of computer program code based on the design of the user graphical user interface. The implementation of the user graphical user interface was achieved by visually dragging and dropping preformed component objects onto a design window. Truly a milestone for providing an easy-to-use computer programming language development environment. Next, HTML not only continued the user-friendly computer programming language objective, but more importantly addressed squarely the data format for the HTML computer program code passed over the World Wide Web. HTML took the computer programming markup language technology, first used by desktop publishing, but more importantly adapted the computer programming markup language technology to the World Wide Web by way of the browser. As such, today, the HTML computer programming language is used by a host of non-professional computer programmers to develop web-based computer programming application solutions. Next, Ruby further contributed to the user-friendly computer programming language objective by creating a computer programming language that applied the Perl computer programming language's scripting features combined with the Smalltalk computer programming language's object-oriented features, an end result that made computer programmers much more productive. Java then further extended the computer programming language's ease of use objective by providing computer programming language universal portability. Universal portability across a wide variety of computer system platforms. Universal portability not only for traditional computer programming application solutions, but more importantly, universal portability for computer programming web-based application solutions. For example, the use of Java applets to extend HTML computer program code to provide human website interactivity so critical for Web 2.0 computer programming application solutions. Next, JavaScript offered Java computer programming concepts in the form of a computer programming scripting language that could be added to HTML computer program code. As such, now non-professional computer programmers could provide website human interactivity to web pages, much like their professional computer programmer counterparts. PHP extended JavaScript originally dedicated for the client side of client server platform architecture, where PHP is used primarily for the server side, thus providing a complete cycle of human website interactivity required for supporting Web 2.0 computer programming application solutions. Finally, XML solves the age-old issue of application programming interfaces. XML creates a universal standard for defining data, irregardless of the structure of the data. Thus, custom programming point-to-point application programming interfaces are no longer required for the exchange of data. As such, today's computer programming application solutions can share the same data, irregardless of the proprietary nature of their native data structures. All this due to a computer programming markup language called XML that extends the HTML computer programming code. Thus, extended markup language, or XML, focuses exclusively on defining the data. That is, the data processed by the web page. Python is a general-purpose, interpreted, high-level computer programming language. Python's design philosophy emphasizes computer program code readability. Python's readability is enhanced by providing a simple, clear, and expressive computer programming language syntax. The Python computer programming language has a large and comprehensive standard class library that promotes reusability. Python supports multiple computer programming language paradigms. However, Python is recognized as complying strictly to the computer programming language object-oriented paradigm. Python features a dynamic data typing system. Dynamic data typing means that the typing of computer program variables is performed automatically. Automatic typing of data combined with automatic memory management allows the computer programmer to concentrate exclusively on the computer program's logic. Python's major use is that of a computer programming scripting language. Python interpreters are available for many computer operating systems. CPython, the reference implementation of Python, is available as free open source software. Thus, CPython development is supported by a community-based development model, as CPython is managed by the nonprofit Python Software Foundation. The Python computer programming language was originally developed by Guido van Rossum in 1991 at the National Research Institute for Mathematics and Computer Science, located in the Netherlands. Python 2.0 was released in 2000. Python 2.0 instituted improvements to the computer programming language development process. Here, the computer programming language development process was shifted to a more transparent, community-backed computer programming language development process. Python 3.0, or Python 3000, was released in 2008. In conclusion, the Python computer programming language was developed to provide a computer programming language that promoted computer program code readability. As such, Python computer program code is uncluttered by using English keywords to replace punctuation that other traditional computer programming languages require. This simplicity of Python is demonstrated by the computer program code example. Note the English keywords that replace the punctuation normally used to demarcate the computer program code to promote readability. This allows the computer programmer to become more productive for developing more reliable, timely, and maintainable computer programming application solutions. Visual Basic is a third-generation, event-driven computer programming language, combined with a visual rapid application integrated development environment. Visual Basic was developed by Microsoft based on its component object model computer programming development model. The Visual Basic computer programming language was first released in 1991. The key feature of Visual Basic is that it was designed to be relatively easy to learn and use. No surprise that Visual Basic was derived from the original BASIC. However, Visual Basic extends the original BASIC computer programming language by providing a visual rapid application integrated development environment, supported by a robust point, drag, drop graphical user interface creation process. A graphical user interface creation process that then generates computer program code. Computer program code generated based on the graphical user interface design. The component object model also adds a preformed family of objects, known collectively as ActiveX objects, where these objects are assembled and combined to provide a complete computer programming application solution based on reusable computer program objects. Thus, this visual rapid application integrated development environment approach facilitates the rapid development of a complete, robust, and diverse set of computer programming application solutions, a set of computer programming application solutions that take advantage of the reuse of preformed component code objects. As such, the computer programmer can now concentrate on the design and development of the computer programming application solution, as opposed to writing computer program code from scratch. Under this scenario, computer program code is generated from the design of the computer program. More importantly, the computer programmer's role has shifted dramatically from writing computer programming code to assembling preformed component objects to provide the computer programming application solution. Microsoft also created computer programming scripting languages, such as Visual Basic for Applications and Visual Basic Script. What's more, VBA and VBScript are syntactically similar to Visual Basic. Visual Basic 1.0, which was released initially, was limited by the lack of preformed component objects. Visual Basic 3.0 mitigated this limitation as a number of third-party developers began to provide an abundance of ActiveX components. Microsoft also added ActiveX components to create a robust visual rapid application integrated development environment, unmatched by anyone else in the industry. All this led to Visual Basic 6.0, released in 1998. In 2008, Visual Basic.NET was released. Visual Basic.NET, which we will discuss with computer programming languages of the 2000s, extended the Visual Basic computer programming language with the .NET framework to support all .NET computer programming languages, including Visual Basic.NET. .NET extended the reusable component object model concept to be computer programming language agnostic. In other words, under .NET, the same computer programming application solution can be developed under a variety of computer programming languages. In conclusion, Visual Basic dramatically changed the way computer programmers develop computer programming application solutions. I have used Visual Basic from the beginning and continue to use it today. I have used it in both teaching and commercial environments. As such, I give much credit to Microsoft for giving us the component object model development concept. In fact, my doctoral dissertation entitled Component Object Model Development Lifecycle supports the concept based on my experiences both as a professor and a developer. While most view Microsoft as a developer of operating system software, I recognize their major contribution as a developer of Visual Rapid Computer Programming Application Solution Development Software, specifically that which was started with Visual Basic. Hypertext Markup Language, or more commonly referred to as HTML, is the main computer programming markup language for displaying web pages. HTML is written in the form of HTML elements consisting of tags enclosed in angle brackets. HTML tags commonly come in pairs. For example, a start tag followed by an end tag. Between the start and end tags, the content is included. The web browser then displays the content for the web page, where the format of the display is based on the HTML tags that sandwich the content. Thus, the purpose of a web browser is to interpret the HTML computer program code and then display the content contained in the HTML program code in the appropriate format on the web page. In doing this, the web browser does not display the HTML tags, but uses the tags to format the content of the web page. So in this case, the HTML computer programming language is based on structural elements or tags organized in a top-down hierarchical framework that determine how the embedded content between the elements is displayed. Taking this technology further to include content beyond text, images, sound, video, and other objects can also be provided as embedded content, thus providing robust interactive web pages. The HTML computer programming language makes all this happen by creating structured documents that include structural semantics for interpreting and displaying text, images, video, sound, and other objects. Next, the computer programming HTML language can be extended by embedding a computer programming scripting language. For example, JavaScript can be added to provide structural programming control structures, such as sequence, repetition, and decision. This all began in 1980 with physicist Tim Berners-Lee. While Tim Berners-Lee was a contractor at the European Organization for Nuclear Research, otherwise known as CERN. At this time, Berners-Lee proposed and prototyped a system called Inquire. The purpose of Inquire was to allow CERN researchers to use and share documents. This was followed in 1989 when Berners-Lee wrote a memo proposing an internet-based hypertext system. Berners-Lee then developed the first HTML specification. In 1991, Berners-Lee followed up with the first web browser and server software to process an HTML file. In conclusion, the development of the HTML computer programming language provides a perfect example of information technology convergence, where three information technologies converged. First, the Internet, or the World Wide Web. Second, the Transport File Protocol for sharing information over the Internet. And third, the computer programming language software for interpreting, displaying, and processing the information, namely the web browser. When these three information technologies converged, the World Wide Web became a reality. Today we have Internet Explorer, XML, HTML5.0, cascading file sheets, JavaScript, Java applets, active server pages, etc. But irregardless of today's information technology advances, one man was responsible for all of this because he set the stage for all three information technologies. That man, Tim Berners-Lee. Ruby is a dynamic, reflective general-purpose, object-oriented computer programming language. The Ruby computer programming language combines the syntax inspired by Perl with features prevalent in the Smalltalk and Python computer programming languages. Ruby was also influenced by the Eiffel and Lisp computer programming languages. Ruby was first designed and developed in 1993 by Yukihiro Matsumoto in Japan. Ruby supports multiple computer programming language paradigms, foremost for Ruby being the computer programming language object-oriented paradigm. Ruby also features a dynamic typing system and automatic memory management. As such, Ruby owes its object-oriented roots to the Smalltalk and Python computer programming languages. The Ruby standard implementation is written in C as a single-pass interpretive computer programming language. Ruby's computer programming language specifications were developed by the Open Standards Promotion Center of the Information Technology Promotion Agency. The specifications were then submitted to the Japanese Industrial Standards Committee. From there, the Ruby computer programming language specifications were submitted to the International Organization for Standardization. Finally, in 2011, Ruby was accepted as a Japanese industrial standard, JIS-X 3017, followed in 2012 by international standard ISO/IEC 30170. Yukihiro Matsumoto's original idea was to create a new computer programming scripting language because Matsumoto wanted a computer programming scripting language that was more powerful than Perl. He also wanted a computer programming language that fit the computer programming language object-oriented paradigm to a greater extent than the Smalltalk and Python computer programming languages. Because this combination of scripting and an object-oriented computer programming languages did not exist, Matsumoto decided to develop his own computer programming language, the result being the Ruby computer programming language, a computer programming language whose main focus was on making computer programmers more productive. In conclusion, the Ruby computer programming language was developed principally to improve computer programmer productivity. Matsumoto believed that happy computer programmers became productive computer programmers. Improved productivity achieved by combining the features of the Perl, Smalltalk, and Python computer programming languages into one single computer programming language. As such, today, Ruby achieved Matsumoto's objective by becoming a very popular computer programming language, especially for Web 2.0 computer programming application solutions. Java is a computer programming language originally developed by James Gosling at Sun Microsystems in 1990. Oracle Corporation acquired Sun Microsystems in 2010. As such, the Java computer programming language is now provided and supported by Oracle Corporation. The Java computer programming language conforms to the computer programming language object-oriented paradigm. Java derives much of its syntax from the C computer programming language. As such, those computer programmers familiar with C can transfer that experience directly to Java. In other words, Java is the object-oriented outgrowth of the C procedural-oriented computer programming language. Java computer programming source code compiles to machine or object code called bytecode. The bytecode is referred to as a Java class or object. These resulting Java classes require a Java virtual machine to produce an executable computer program. The Java Virtual Machine, or JVM, is specific to each particular computer machine platform. This is how Java achieves portability between diverse computer machine platforms. Thus, if a computer machine platform is installed a Java virtual machine, bytecode produced on one computer can be executed on a second computer, providing the second computer has a Java virtual machine installed specific to that computer machine platform. In this way, the Java computer programming language has few implementation dependencies. This means that a Java class that runs on one computer machine platform does not need to be recompiled to run on another computer machine platform. No surprise today, the Java computer programming language is one of the most popular computer programming languages. In fact, Java is used by a reported 10 million computer programmers. Java was initially called Oak after an oak tree that stood outside Gosling's office at Sun Microsystems. Later, Java went by the name Green. However, both these names were taken, thus finally settling on the name Java. My guess the name Java has something to do with the large quantities of coffee consumed by Java's creators. In 1995, Sun Microsystems released the first public implementation of the Java computer programming language called Java 1.0. For Java 1.0, Sun promised write once, run anywhere. Write once, run anywhere promised no cost runtimes on all popular computer machine platforms. Major web browsers soon incorporated the ability to run Java applets within web pages. This launched Java as a very popular computer programming language. In 1999, Java 2 was released initially as J2SE 1.2. This led to new versions with multiple configurations, built for different types of computer machine platforms. One version, J2EE, targeted enterprise applications. Another version, J2ME, targeted mobile applications. For example, smartphones. In 2006, J2SE was designated the standard edition for marketing purposes. Sun Microsystems renamed the new J2 versions as Java EE, Java ME, and Java SE, respectively. As such, today, Java runs on a diverse set of computer machine platforms from smartphones to mainframes. In conclusion, Java is a perfect example of a computer programming language that was ahead of its time. Originally created in 1991 to be used to control electronic devices such as small appliances, digital cable set-top boxes, home security systems, etc. Unfortunately, these electronic devices had not matured enough to achieve the program-controlled electronic device objective. Then in 1995, an unexpected information technology did mature, namely the World Wide Web. Web pages now required more user interaction, hence Java applets, which extended the already existing robust Java class libraries, could provide this user interaction. Thus, Java finally had a demanding value-added computer programming application solution or killer application. The information technology community finally recognized the Java computer programming language for its contribution to making the World Wide Web a human interactive medium. For example, social media, online shopping, etc. As such, today, Java is probably the most used computer programming language for a diverse set of computer programming application solutions, a computer programming language that owes its heritage to the C computer programming language, a computer programming language that is free, object-oriented, and portable across a multiple set of computer machine platforms. Computer machine platforms for everything from smartphones to mainframe computers. A computer programming language used to control electronic devices of all sizes and shapes, which was the original killer application for the computer programming language. Today, over 10 billion electronic devices are controlled by computer program code. Computer program code written in the Java computer programming language. What's more, Java, in my opinion, forced Microsoft to create the C# computer programming language for the .NET framework. By the way, C# inherits the same syntactical rules used for the Java computer programming language. The same syntactical rules originated in the C computer programming language. JavaScript is a prototype-based computer programming scripting language. The JavaScript computer programming language supports the computer programming language object-oriented paradigm. JavaScript led to the formation of the standard for computer programming scripting languages, namely the ECMA Script Computer Programming Language Standard. JavaScript is primarily used to develop computer programming application solutions for the client side of the client-server platform architecture. For the most part, the JavaScript computer program language is used to extend the functionality of the web browser. JavaScript was first introduced to extend the Netscape web browser. This allowed the Netscape browser, called Navigator, to create enhanced and dynamic websites by using the JavaScript computer programming language to provide structured programming computer program constructs that can easily be added to traditional HTML computer program code. Structured computer programming constructs supporting sequence, repetition, and decision control structures. This then provides a level of user interaction required for e-commerce websites. For example, online shopping, travel reservations, and social media. In fact, JavaScript set the stage for what today we call Web 2.0 computer programming application solutions, at least from the client side of client-server platform architecture. No surprise, the JavaScript computer programming language inherits its computer programming language syntax from the C computer programming language, much like the Java computer programming language did. Although JavaScript copies computer programming language features from the Java computer programming language, the two computer programming languages are very different. JavaScript is based on scripting, where JavaScript is embedded in HTML code, then interpreted and executed by a web browser. Java, on the other hand, is a standalone compiled computer programming language, extended by a robust class library of object code components, where the object code components or classes are referenced or called by the web browser and then execute independently of the web browser. The JavaScript computer programming language was originally developed by Netscape by Brendan Eich. Netscape at the time was involved in what was called the web browser wars with Microsoft. That is, Netscape's Navigator web browser versus Microsoft's Internet Explorer web browser. Microsoft was offering Internet Explorer bundled with its Windows operating system, thus trying to lock out Netscape's Navigator from Windows-based personal computers. As such, Netscape had to counter by providing Navigator with extended capability over Internet Explorer. The answer was JavaScript. Netscape chose a lightweight interpreted scripting computer programming language that would include a Java-like computer programming language syntax, but more importantly would appeal to non-professional computer programmers. Those non-professional computer programmers that could develop HTML code for client-side web pages, extended with the JavaScript computer programming language. JavaScript was first developed under the name Mocha LiveScript in 1995. Shortly later, Mocha LiveScript was renamed JavaScript when it was deployed in the Netscape web browser version 2.0. The change of the name from LiveScript to JavaScript roughly coincided with Netscape adding support for Java technology in its Netscape Navigator web browser, namely Java Applets. No doubt the final choice of the name caused much confusion because it gave the impression that the JavaScript computer programming language was a spin-off of the Java computer programming language. This, of course, was not the case. Many believe the name JavaScript was merely a marketing ploy, by Netscape to take advantage of the Java computer programming language's newfound popularity. Many also believe that the name change was part of a co-marketing deal between Netscape and Sun Microsystems. Remember, at this time, Sun Microsystems was also battling Microsoft over the Java computer programming language's source code standard. Early versions of Microsoft's Visual Studio had a version of Java that Microsoft had modified to suit extensions to the computer programming language they required. Since Sun Microsystems was the creator of the Java computer programming language, Sun Microsystems vehemently objected to Microsoft making these changes. The result was litigation instituted by Sun Microsystems. Today, no surprise is that the C# computer programming language has become Microsoft's version of Java that is provided with Visual Studio.net. In conclusion, although Netscape Navigator in the long run gave way to Internet Explorer, the JavaScript computer programming language survived and today is thriving by providing computer programming functions to a host of web browsers, including Internet Explorer. Thriving because it can easily be used by non-professional computer programmers to extend computer programming language functionality of their base HTML computer program code, thus allowing the user website human interactivity required for Web 2.0 computer programming application solutions. User website human interactivity that is a necessity for driving today's e-commerce global economy. PHP is an open source, general purpose scripting computer programming language. The PHP computer programming language is used primarily to provide server-side computer programming application solutions operating on the client-server platform architecture. No surprise, PHP was originally designed for website development to produce dynamic websites. To produce dynamic websites, PHP computer program code is embedded directly into the HTML computer program code. This approach differs from that of calling an external computer program to process the submitted HTML computer program code. The embedded PHP computer program code is then interpreted by the PHP processor deployed on the web server. Next, the PHP processor then produces the resulting server web page. The resulting web page, or HTML computer program code, which is then returned to the client side of the client-server platform architecture. The PHP computer programming language can be deployed on most web servers. PHP can also be deployed on a variety of computer system platforms. Best of all, the PHP computer programming language is open source, so PHP is free. This makes PHP a strong competitor of Microsoft's Active Server Pages. Active Server Pages, of course, are not free. What's more, Active Server Pages are restricted to the Windows Server computer system platform. As a result, today PHP is installed on more than 20 million websites using more than 1 million web servers. The PHP computer programming language was originally created by Rasmus Lerdorf in 1995. The main implementation of PHP is now produced and supported by the PHP Group. The PHP Group serves as the formal reference standard for the PHP computer programming language. PHP is free software released under a PHP open source license. Originally, PHP stood for Personal Homepage. Now PHP stands for Hypertext Preprocessor. PHP development first began in 1994. These scripts were called Personal Homepage Tools. They were created for the purpose of maintaining Lerdorf's homepage. The scripts perform tasks such as displaying Lerdorf's resume, as well as recording his web page traffic. This all led to PHP's first release in 1995. Lertoff rewrote these original scripts as a common gateway interface using the C computer programming language. This extended the original scripts by allowing the submitted web forms to communicate directly with databases hosted on the web server. Lertoff called this implementation Personal Homepage Forms Interpreter, or PHPFI. Thus now PHPFI could be used to build simple dynamic web applications. In conclusion, PHP set the stage for server-side processing for computer systems based on client-server platform architecture, especially where the server side includes a web server. PHP completed the full cycle of user interaction requirement for dynamic websites, namely the ability for a web form initiated at the client side to be processed against a database hosted by the server-side's web server. The full cycle of user interaction required for online shopping, travel reservations, etc. What's more, PHP is open source, free, and supported by a variety of computer system platforms. PHP also drove the major proprietary vendors to create the same full-cycle user interaction capability throughout the entire client-server platform architecture. For example, without PHP, we might not have Microsoft's active server pages. Extensible Markup Language, or XML, is a computer programming markup language which defines a set of rules for encoding of data. Encoded data that is passed between diverse computer programming application solutions, where the encoded data is provided in a format that is both human readable as well as computer readable. A XML computer programming language parser parses the data sent or received by the diverse computer programming application solutions in accordance with the set of rules or schemas that define the data. The schemas or rules that define the data accompany the actual data. The actual data sent or received by the diverse computer programming application solutions. As such, the XML computer programming language has become the lingua franca for connecting diverse computer programming application solutions. XML 1.0 is the specification standard adopted by the World Wide Web Consortium. The design goals of XML emphasize simplicity, generality, and usability. To this end, XML is based on a text data format, a format widely accepted throughout the world. As such, the XML computer programming language is used to represent a wide, diverse, and arbitrary set of data structures. For example, ActiveX-DataObjects.net or ADO.net represents all data structures based on the XML computer programming language. More importantly, web services could not be shared among diverse computer programming application solutions without XML. As such, many of today's application programming interfaces, or APIs, depend upon XML. What's more, today, hundreds of computer programming languages have been extended through the incorporation of the XML computer programming language, namely most proprietary and open source computer software packages. To name a few, such as Microsoft Office, OpenOffice, iWork, etc. Even more important, XML is responsible for a number of API protocols, including RSS, Atom, SOAP, and XHTML. XML was first debated by a working group of 11 members and a 150-member interest group. A record of design decisions and their rationales was compiled by Michael McQueen in 1997. James Clark served as technical lead of the working group. Clark contributed the name XML. Ironically, the XML working group never met face-to-face, as the design of XML was accomplished using a combination of email and weekly teleconferences. culminating with the major design decisions reached in 1996. Further design work continued through 1997. Finally, XML 1.0 became a World Wide Web Consortium recommendation in 1998. In conclusion, XML has revolutionized the way data is communicated between diverse computer programming application solutions. Having spent a great deal of time in the enterprise application interface industry, I can personally testify the import that XML has had on this industry. No longer were custom programming point-to-point interfaces required, because XML has created a universal standard for defining data, irregardless of the structure of the data, because the XML file, along with the XML schema, not only contains the data, but defines the data irregardless of its native data structure. As such, XML has extended all computer programming languages by providing a universal standard for defining data, providing the computer programming languages incorporate an XML parser as an integral part of their computer programming language.